Eric Hockwald. I'm a senior computer science major.
I'm Will Luna. I'm an interdisciplinary studies major.
Nathan Watts. I'm a junior computer science and music double major.
I'm Rana Tenbrink. I'm a senior in human factors and computer science. Something you may have come across in music theory called the Tonitz diagram, which is, think of a normal keyboard, kind of increasing frequencies, but in this way the notes are laid out differently so that we have kind of a triangular arrangement of chords, and each node where triangles meet is an individual note. So pressing on a node signals one note, and pressing on a triangle signals an entire 3-note chord, and pressing on a line between two nodes would be 2 notes playing at the same time.
All the blue ones are minor chords and all the red ones are major chords. And if you go across horizontally, the notes change by a perfect fifth. And if you go up and down, it changes by a major third. So you can get interesting chord progressions by pressing adjacent triangles, kind of like Bach chorale sort of things. Yeah.
It's a way of understanding musical relationships non-linearly. It's not like a linear setup that you have to remember the relations yourself, but you can kind of see how they move through space in really different visual patterns.
Because it's an isotonic arrangement, the same patterns have the same shape everywhere on it. So it's really, that's why it's so easy to just do like 1, 4, 5, 1 anywhere on the keyboard.
And there is a transpose control.
Yes. It's semitones right now, but you can actually adjust that. One of the neat things is that you can change that so that it would transpose by major thirds, for example, in which case it would shift the Tonitz diagram this way, or minor thirds shifting it that way, or fifths shifting it that way, or you could do octaves, or there's a lot of flexibility and a lot of options with the transposition there.
And we decided to implement this diagram fairly literally. So at each node, there's an FSR under it.
So we have a piece of acrylic that you can see here on the top that was laser cut into those triangle pieces, and each of those is laid atop 3 different rubber bumpers, and each of those bumpers is in turn resting on an FSR.
Each tip of the triangle is resting on a bumper which has a force sensing resistor under it. It distributes the force pretty evenly among the 3, so you get a nice chord.
Physically, but there's not really it's not continuous.
We have 32 voice polyphonic aftertouch. There aren't that many MIDI channels, so it's pretty much impossible to do within reason. We're hosting 32 different VST plugins within Max, sending the aftertouch to that instance.
In some, there are a lot of technical challenges unique to having total polyphony over your instrument, where you could have a finger on every single vertex and it would be playing every single note simultaneously, and they would all be sending different aftertouch values. There are only 16 analog pins on an Arduino itself, and so we actually had to split it across 2 different Arduinos. You can't simply say, all right, the top leftmost vertex is going to be assigned to the first analog pin, and then so on and so forth, progressing as you'd read from left to right, top to bottom. You have to parse out, basically split the board in half, and read from 2 different simultaneously, which is kind of hard to conglomerate in that way. This was more or less
Pretty much.
yeah.
That was the alpha.
It's a different shape.
Half the size.
A smaller range.
Does it have all 24 pitches in it? Or 12?
No, this only has,
It's 1 row short.
yeah. It's a little bit of a rat's nest right now. The face itself has 2 parts. It has the part over here with buttons, sliders, etc. And then it has the part over here with the bumpers and the FSRs. And these are both resting on little wooden blocks in all of the corners.
So we have this lovely thing set up where we can record loops of chords, and it'll play them back at a regular speed.
To take advantage of what we talked about before in terms of this different way to visualize note relationships, we were planning on using LEDs, first of all, underneath to illuminate the note that you were playing, but also when you record a loop, for the LEDs to light up in the pattern that the notes are being played, so you can even sit back and you can watch the pattern of the music. If we could save those patterns and then you could play a piece, you could play a 5-minute long piece with a bunch of loops, whatever, and then at the end we could have visualized the tapestry of music that you played, and you could put that on your wall or something and be like, this is what my piece of music looks like. Having it be in a visual sense rather than just an auditory sense would be a really good learning tool for learning about music relationships.